Section 5, Machine Guarding for General Industry. AskMySafetyExpert.com will now attempt to answer some of the most questions we face in life as civilized individuals. Among those questions is how we can safely guard our machinery to use it most effectively at the greatest factor of safety built in. By the time this program is finished, you will understand what your legal obligations are in using and protecting things like in running nip points and pinch points. Let's get started. Contents of our machine guarding program are as follows. Section 1, Introduction to Machine Guarding and General Industry. Section 2, Importance of Machine Guarding Discussion. Section 3, Basic Hazards Involving Machinery including Point of Operation and Power Transmission Device. Section 4, Methodologies for Controlling Moving Parts Hazards of Machinery.
Introduction to Machine Guarding. Crushed hands and arms, severed fingers, blindness, possible machinery-related injuries is as long as it is horrifying. There seem to be as many hazards created by moving machine parts as there are types of machines. Safeguards are essential for protecting workers from needless and preventable injuries.
Intro to Machine Guarding. A good rule to remember is, any machine part, function, or process which may cause injury must be safeguarded. Where the operation of a machine or contact with it can injure the operator or others in the vicinity, the hazards must be either eliminated or controlled.
Intro to Machine Guarding General Industry. Machine shop have lathe, milling, drilling, grinding equipment among many others providing hazard exposure. This presentation examines hazards of mechanical motion and actions and presents some techniques for protecting workers from these hazards. The hazards created by different kinds of motions and the requirements for effective safeguards and training needs.
Intro to Machine Guarding General Industry. Any machine part, function, or process which may cause injury must be safeguarded. Where the operation of a machine or contact with it can injure the operator or others in the vicinity, the hazards must be either eliminated or controlled.
Machine guarding principles. If it moves, it merits the attention of the machine shop worker and management.
Machine guarding principles. The purpose of machine guarding is to protect against and prevent injury from point of operation in running nit points, rotating parts, fly-in chips, and sparks.
Machine guarding principles. Sapardo machine guarding, along with some others, standard provides general guarding requirements. In addition to specific requirements for woodworking machinery, abrasive wheel machinery, as well as mechanical power presses and power transmission devices.
Machine guarding principles. NIP points. Dangerous moving parts in 3 basic areas requires safeguarding.
Machine guarding principles: the point of operation, that point where work is performed. Examples are cutting, shaping, boring, forming, grinding, turning, shearing, punching, bending, drilling.
Machine guarding principles. 2. Power transmission apparatus. All components of the mechanical system which transmit energy to the part of the machine performing the work. Examples are flywheels, couplings, pulleys, cams, spindles, belts, chains, cranks, sprockets, gears, shafts, rods.
Moving machinery hazards. Other moving parts: all parts of the machine which move while the machine is working. Examples of this are reciprocating, rotating, transverse feed mechanisms. Can you think of examples on your work site?
A wide variety of mechanical motions and actions may present hazards to the industrial worker. These can include the movement of rotating members, reciprocating arms, moving belts, meshing gears, cutting teeth, and any parts. These different types of hazardous mechanical motions and actions are basic in varying combinations to nearly all machine. Moving machinery hazards. Rotating motion can be dangerous. Even smooth, slowly rotating shafts can grip clothing, and through mere skin contact force an arm or hand into a dangerous position. Collars, couplings, cams, clutches, flywheels, shaft ends, spindles, meshing gears, and horizontal or vertical shafting are some examples of common rotating mechanisms which may be hazardous. The danger increases when projections such as set screws, bolts, nicks, abrasions, and projecting keys or set screws are exposed on rotating parts, as shown in the drawing to the left.
Moving machinery hazards. There are three main and running points. 1. Rotating motion. Examples: flywheels, shafts, pulleys, gear sprockets, couplings. Parts rotating in opposite direction, rotating and tangentially moving parts, rotating and fixed parts. Hazardous mechanical motions and actions. Motions: 2. Reciprocating, 3. Transverse. Examples of reciprocating machinery: scissor lifts, shaker screens, feed tables.
Moving machinery hazards. Reciprocating hazards. Back and forth. Up and down may be struck by or caught between a moving and stationary part. Examples include knife sharpeners, slicers, feeding ejecting parts.
Machine guarding safety, transverse motion straight and continuous line. Conveyor lines, lengthy belts, may be struck or caught in a pinch or shear point by the moving part. Machine guarding, transverse motion. Actions: 1. Cutting 2. Shearing 3. Bending 4. Punching.
Controlling machine hazards. There are many ways to safeguard machines. The type of operation, the size or shape of stock, the method of handling, the physical layout of the work area, the type of material, and production requirements. As a general rule, power transmission apparatus is best protected by fixed guards that enclose the danger areas.
Moving machinery hazards. Safeguarding strategies include guards, fixed, interlocked, adjustable, self-adjusting devices, presence sensing, pullback, restraints, controls/trips, gates,
Machine guarding safety, controlling the hazards. Another safeguarding strategies may include location and or distance, feeding ejection methods.
Machine guarding safety, controlling the hazards. Miscellaneous aids can help reduce exposure. See the following. 1. Awareness barriers. 2. Protective shields. 3. Hand feeding holding tools. 4. Anti-restart devices.
General industry and machine guarding. At least some of the equipment about to be presented can be found in your maintenance shop area. This section is intended to familiarize you with the safety aspects of using it.
Effective machine guarding techniques. I must prevent any contact to the machine hazard. Plus 2. They must be around, over, through, or under the guard. So designed and constructed as to prevent the operator part of his or her body in the danger zone during the operating cycle.
Effective machine guarding. Guards must not present a hazard in itself or create interference. Guards must not allow objects to fall into moving parts. The guard should allow safe maintenance and lubrication.
Effective machine guarding. The last criteria for erecting effective machine guarding are affixed to the machine where possible and remains secure. Conforms with other appropriate standards such as ANSI, manufacturer specifications, etc.
Effective machine guarding. Guards are physical barriers which prevent access to danger areas. Types of effective guards are the following. 1. Fixed guards, permanent part of the machine.
Machine guarding. Effective guarding techniques. Careful interlocked guards can be bypassed. This electric interlock on a trash compactor was taped down. When opened or removed, the tripping mechanism and or power automatically shuts off or disengages. Machine cannot cycle or be started until the guard is back in place. Use electrical, mechanical, hydraulic, or pneumatic power. Replacing the guard should not automatically restart the machine.
Machine guarding safety, adjustable guards. Allow flexibility in accommodating various sizes of stock.
Self-adjusting guards explained. Openings are determined by the movement of stock. Guard is pushed away as stock is introduced. Opening is only large enough to admit the stock. Guard returns to rest position after stock passes through.
Machine guarding, devices to control hazard. A safety device controls access to danger areas and may perform one of several functions. It may stop the machine if a hand or any part of the body is inadvertently placed in the danger area. Restrain or withdraw the operator's hands from the danger area during operation.
Machine guarding devices to control hazard require the operator to use both hands on machine controls. Provide a barrier which is synchronized with the operating cycle of the machine in order to prevent entry to the danger area during the hazardous part of the cycle.
Machine guarding, presence sensing devices. Photoelectric, optical, uses a system of light sources and controls which can interrupt the machine's operating cycle. Radio frequency, capacitance, uses a radio beam that is part of the machine control circuit. When the capacitance field is broken, the machine will stop or will not activate. Electromechanical guards. Has a probe or contact bar which descends to a predetermined distance when the operator initiates the machine cycle. If there is an obstruction preventing it from descending its full predetermined distance, the control circuit does not activate the machine cycle.
Machine guarding. Pullback devices utilize a series of cables attached to the operator's hands, wrists, and/or arms. This type of device is primarily used on machines with stroking action. Slack is taken up during the downstroke cycle, pulling the operator's hands from the point of operation. If still there when the slide ram is up between cycles, the operator is allowed access to the point of operation.
Machine guarding, restraint devices. The restraint, hold-out, device utilizes cables or straps that are attached to the operator's hands at a fixed point. The cables or straps must be adjusted to let the operator's hands travel within a predetermined safe area. There is no extending or retracting action involved. Consequently, hand-feeding tools are often necessary if the operation involves placing material into the danger area. Machine guarding, safety trip controls. Provides a quick means for deactivating the machine in an emergency situation. A pressure-sensitive bar, strategically placed, will deactivate the machine when depressed. Safety tripwire cables may also be located around the perimeter or near the danger area.
Machine guarding, two-hand controls requires constant, concurrent pressure by the operator to activate the machine. With this type of device, the operator's hands are required to be at a safe location, on the control buttons, and at a safe distance from the danger area.
Machine guarding, two-hand trips controls. This device requires concurrent application of both the operator's control buttons to activate the machine cycle. after which the hands are free.
Machine guarding, two-hand control devices. Two-hand controls and two-hand trips must incorporate both anti-tie down and anti-repeat features. Anti-tie down prevents tying one button down and still being able to cycle the machine by depressing the other. Anti-repeat prevents continuous cycling.
A gate is a movable barrier which protects the operator at the point of operation before the machine cycle can be started. They are usually designed to operate with each machine cycle. Two types. Type A remains closed during entire cycle. Type B remains closed during downstroke only.
The machine or its dangerous moving parts are positioned so that the hazardous areas are not accessible or do not present a hazard during normal operation. Walls, one method of control. Barriers, fences, another method. Height above worker, third method.
Automatic feeding/ejection. Operator involvement is not necessary after the machine is set up.
Semi-automatic feeding ejection manually feed without reaching into the point of operation or other danger zones.
Machine guarding, robots. Machines that load and unload stock, assemble parts, transfer objects, and perform other tasks, otherwise done by the operator. Robot concerns include being struck by robotic arms into the mechanisms within its working envelope.
Most common injuries are being struck by the end effector, claw on the end, and being pinned between the end effector and a stationary object. Also, possible malfunctions and or missed steps can surprise nearby workers. Recommended Safety Standard, ANSI, RIA 15.06-1999.
Miscellaneous aids do not give complete protection from machine hazards, but can assist in moving stock, deflecting minor chips, or providing awareness. Examples include awareness barriers, ropes, shields, holding tools, and push sticks or blocks. These aids do not replace the need for personal protective equipment or guarding.
Machine guarding training requirements. Discussion of hazardous exposures and control measures, hazardous motions, hazardous actions. Potential of flying ejected material. Fire combustion potential. Appropriate personal protective equipment and clothing. Health hazards, air quality. Machine guarding training requirements. Noise and vibration metalworking fluids. Equipment-specific training, hands-on, proper operation of safeguards. Limitations of safeguards. Maintenance and care. Inspection or adjustment or /placement.
Machine guarding training requirements. Clarification of manufacturer requirements. Instruction on when safeguard is discovered damaged, missing, etc. Training and relevant retraining must be provided for new operators and maintenance/setup employees. Retrain affected employees when new or altered safeguards are used.
Here is when the need to retrain employees is mandated, when the employee S is assigned to a new machine or operation, and whenever worker deficiencies are discovered.
Machine Guarding Safety Summary. Item 1. Safeguards are essential for protecting workers from needless and preventable injuries. Item 2. A good rule to remember is, any machine part, function, or process which may cause injury must be safeguarded. Item 3. There are many ways to safeguard machines. The type of operation, the size or shape of stock, the method of handling. Item 4. Effective guarding must prevent any contact to the machine hazard plus.
Effective guarding. They must be around, over, through, or under the guard. So designed and constructed as to prevent the operator part of his/her body in the danger zone during the operating cycle. The machine or its dangerous moving parts are positioned so that the hazardous areas are not accessible.
Machine Guarding for Shop Safety Summary. The restraint, holdout, device utilizes cables or straps that are attached to the operator's hands at a fixed point. The cables or straps must be adjusted to let the operator's hands travel within a predetermined safe area. Safe trip controls provide the quick means for deactivating the machine in an emergency situation. Robot concerns include being struck by robotic arms and other mechanisms within or near its working envelope.
Machine guarding for machine shop summary. Require the operator to use both hands on machine controls. Provide a barrier which is synchronized with the operating cycle of the machine in order to prevent entry to the danger area during the hazardous part of the cycle.